Okay, so today our topic is still AR application, collaborate data collection of a tablet product. Okay, so I'm Hutong Fan from SuperMap. Yeah, here is about the GIS 11i architecture, and our main character today is about the tablet from Android and iOS. And the tablet is one of the products from our terminal GIS. Okay, so that is belongs to the terminal GIS SDK for mobile. And for the tablet, that product support all the popular operation systems of mobile devices. You see the Android and iOS, and you can get this application from the Android app stores or Google Play, of course, and App Store. And for all users, you can download that tablet application and get an experience. Okay, so here we all have horizontal and vertical screen versions in their tablet, so matching different devices and usage scenarios. So for example, when doing a field data collection outside, the experience of using the application with larger icon and screen on tablet, which will much better than finishing your work on a smartphone. So the adaptability on different devices is very important. Okay, so here is about a brief introduction for all the function models in the tablet. Okay, so we have 10 models here in our tablet product. Okay, so for the AR functions, we have the AR survey, AR map, and AR analysis. And basic viewing functions like map build for the 2D maps, and scene view for the broad multi-type of 3D scenes, okay, three-dimensional scenes. And map creating data processing functions like the map and data processing and the plotting, and also the field survey support functions like the surveying and navigation. Okay, so today our my introduction will continue with these 4 topics. Okay, so first about data preparation and AR map effect presentation and co-work serving tasks. And in the end, I will have a brief talking about the customized development. Okay, so first about the data preparation. Okay, so this in my introduction here today, the data preparation is most about the beam model. Okay, so we will use Revit as an example to prepare for the AR example data, and we support many 3D beam models from Revit, CATIA, and here in my slide. Okay. So first is about the format conversion. So actually, as we said before, we have export plugins in many different BIM 3D modeling software products and support importing into the desktop. Okay, so here is with the help of the plugin Revit. Okay, plugin in the Revit here, you can convert the Revit data format to the file data source, okay, to the UDB and UDD file data source format. Okay, so generally one project in the modeling software products will be exported to a file data source. Okay, then we just open the file data source, export it from the Revit in the SuperMap desktop software. So we can import the models we have already converted, okay, into newly created scene here, and generate the scene cache with the selection of the droplets by right-clicking on the scene file. And here is the 2 important settings here we recommended. It's about the compress tab and the S3M version select. Okay, so after the generation, so we will get several generated 3D cache files. So here is about the workspace file here. And then we can open the workspace file which was created with the 3D cache is this file. Okay, and we will create a new file data source and create new attribute table data set named AR scene under the data source and construction the fields and input the corresponding attribute data. Okay, so here then we just save the file data source and workspace, and we can process all the 3D beam models according to the procedure above and to get the different different workspace and different file data sources, okay, for the further using, and we will import that into that tablet just for the further using. Okay, so here is about the example of the data preparation. We have 3 different beam models here, and also we will show that later. Now here's about the copy the offline data. So we have already created that, okay, we have finished our preparation process, okay, preparation procedure for all the models. And here we need to copy that to our mobile, okay? So here we will use the Android phone, okay, Android smartphone. So here is Huawei, okay, so for this example. And first, just, of course, you need to, because we use, this topic is about copy the offline data. So we need to link the mobile device to the computer and allow to copy the files. Okay, and we'll copy the created workspace with 3D cache. So here's about the 3-1 about Apple pipe and internal sense and SuperMap building these 3 things to the directory of the device. Okay, so this directory belongs to your Android phone, and it's under the tablet. Okay, so under that product. Okay. Now here is about to load the offline data. So you need to open your tablet and log into the SuperMap tablet, set the license. Okay, so we also provide the trial license. Okay, and or you can try to use the your SuperMap online account to try to use the tablet. Okay, so we import the workspace with the created 3D cache data. So here we click on the profile, and here is good. Here us to import our data. Okay, so when after we click on the import data, so depending on the size of the generated 3D cache, okay, so it will take different times to import. Okay, so it will cost different time. So if our 3D cache or models too big, of course, that will stuck to that page for some time. You know, it was loading. It's loading that data, loading that 3D cache into your tablet. Okay, so don't be such hurry, be such scared for that. Here's about another part about published online data service. Okay, so based on that, so here we will use the iServer product. Okay, so we can click on the quickly publish service and select the workspace as a data source. Okay, and release the REST, the REST 3D service. So we publish the REST 3D cache service based on the iServer. Okay, so use the remote browse to the directory of generated 3D scene cache and select the workspace as the data source. Okay, also the data source, okay, also the workspace file is we generated before, okay, in the iDesktop. And here we select the REST 3D service tab, and publish the 3D service will appear after the successful publication. So here, for example, is about the 3D SuperMap building. It's good to, it's already published on the iServer. So this is the REST 3D service, and you can input. Okay, so you can input that. Input your address into that tablet, okay, into our tablet product. Here is the online option here, which is good for us to use the iServer address. But I need to point out that the iServer need to set up on the public server. Okay, the iServer product need to set up on a public server. So this URL is open to the public. Then we can use this address to load the data in the workspace. Okay, and then here's about the AR map effect presentation. So first, I will have a brief introduction about what is the AR map. So AR map is a new type map for live view, data querying, real-time interactive editing, and other capabilities. Okay, we support for adding the points of interest, okay, vectors, effects, models, and three-dimensional layer and vector in the form of AR layers. And also we support the AR layer management such as add, delete, rename, set visible distance, and other operations. Okay, so here in the tablet, we will create a new AR map with the beam model. We just copy that or load that from the online or copy that from our computer. Okay, so here we will use the AR map function, okay, in the iTablet, okay, from the index of the iTablet. Okay, so here, the first, we need to calibrate position with the GPS. So here, we use the GPS position here, and also we will, I will introduce another way, okay, in the coming slides. Okay, so here we need to identifying the horizontal surface. We need to keep the device vertical in this way and rotate that very slowly and add the beam model. Here, click add to add the beam model. So the users slowly, if you sometimes if you keep that, keep your device horizontal and still show this way, still show this screen, and we need to slowly rotate that in the circle to recognize the current environment. Okay, so that will happen. That will happen. Yeah. So after moving the device, the realistic scene captured by the camera in the real time will be displayed on your screen. Okay, and here we can click on the add here to add the beam model. Okay. So here is about here we can see here's the models. Okay, here are the beam models we have already copied into the smartphone, into the Android smartphone. Okay, and we can select the model and click on the edit thing to have the modification of the scale, of the translation, and the rotation. Okay, so we can have that modification. We can rotate and pan the model. All right. So with the data preparation procedure, so the beam model should appear within the 10-meter radius from the user, from our service. Okay, so if the model is not visible at first, you can just look for it and by adjusting the direction. All right, so here we also provide a new way for the positioning. It's about the image positioning. So with the QR code, which contains the information of geographic coordinate data. So we can also do the calibration process with the image positioning. Okay. So here we just have a break look of about the effect demonstration. So first about the tunnel. Okay, it's about the subway tunnel. So here we can see we have already loaded that beam model into our tablet. Okay, so here we can make some modification of the translation, and with the phone we're walking. You can see we can check the detailed. We can check the detailed things in the tunnel. Okay, in the subway tunnel. But that is really a good effect. With the AR map And also here's about the pipe. So here's in the SuperMap building. Oh, I thought that was just dropped. I just reshare again. Okay, I'm sorry for my network condition. That's really bad. Okay, so here we just continue our report, our introduction. Okay, so here's about still we will look back again about the pipeline network. Okay, so here is about pipeline. We can add that into the iTablet for the AR effect demonstration. So we can move, we have the modification of the translation of the pipeline. Okay, so we can also change the sliding coefficient, and that will change. So how big you're moving how large step you're moving the pipeline or other beam models. So here is about the buildings. Okay, here's about the buildings, building beam. Okay, so we just open the model, and here we can also for translation for rotation. Okay, and we can have a brief check for the model of the building. Okay, so that's really good effective. So it's good effect. Okay, we can have the rotation here. All right. So also, so here's some others effect we are able to realize in the tablet. So here's about add video. Okay, we support adding pictures, videos, web pages, and other point of interest to create AR maps. And for we also predefined flags, terrain, aircraft, Earth, and many other models support downloading into the devices and adding to the AR maps. And we also predefined some special effect. It's about autumn leaves, lightning, winter snow, spring flowers, and many other effects, supporting downloading into the devices and also adding into our AR map. Okay, so for the next part is about the co-work serving task. So this task is dedicated server or cloud services based. Okay, and perform co-work serving task after publishing the serving information layer. Okay. So first about dedicated server and cloud services. So we need these iPortal or the SuperMap Online supported to process, okay, to use this co-work serving task. Okay, so here we provide two ways to publish the co-work data service. Okay, so first about based on the iPortal server, this page, we can create serving user group and publish data service. And of course, the iPortal server will also need to publish. We also need to set up this on public. Okay, on a public server. Okay, so another way we can use the with the help of the SuperMap Online, so we can create a serving user group on SuperMap Online cloud service and publish data service. Okay, so here for the example here, and we will use the SuperMap Online as a helper for the co-work serving. Okay, so first of all, we need to create a group. So in this example, we create serving co-work group based on the SuperMap Online service and invite the group members. So here is about data preparation. So the data created in a tablet can be used to add multimedia data, such as the pictures and videos, in the follow-up field collections activities as shown later. So so later we will see we can add the photo or the video into our data set. Okay, so here we create a new data source and data set here in our tablet and share them to the SuperMap online. So here's the process. We create new data source, create a data set, okay, of the point and region data. We have two different data sets here and share with the SuperMap online account. Here with the shared data set, we can publish the data in the REST, in the REST data service format. Okay, so we can publish here and we can add that group. Okay, so we can create the serving cowork group. Then we are going to create online serving cowork task on the tablet. So back to the tablet and open the Explorer page here, and we can find the online cowork option and choose the specific group we need to complete the survey task together and click on Add New Task. Okay, so we can choosing the surveying on the tablet and select the specific map and choose the cowork survey members and confirm. Here's the end of create a cowork task. So here's the whole procedure in the tablet to create the online cowork task. Okay, and this is about the service. And here is about the service process. And we have briefly introduced about serving process and the result here. So we're choosing the serving model, serving update surveys, and we just update what we collected and submit the survey result and update the surveys on the device of other users. So here we can have some brief look in these slides with two videos and a picture. Okay. So the first video here has a brief look of the survey process of one person. So in a tablet, we have different ways to collect the data. In this video, the operator collecting the region data with clicking on the screen. And we also support use the GPS location of the operator to proceed the survey task. So after creating, we can set the name of the region and also here take the pictures or record a video to note the real world situation. We can see successfully uploaded and only with the tablet, so only with the dataset, created by a tablet, we can use this multiple media. We can add this multiple media like photo or videos into our dataset. Okay, that's a really easy way to add this into the dataset. Okay, so here, this from the picture in the middle, you can see the tablet has already updated the surveying data from two different locations in China. So here's the Sichuan and Beijing, two different locations, and we have already we all finished our their cowork surveying task. Okay, so here is about data service synchronization and consolidation, and we can check. Okay, which is I played that video with the data surveys. Okay, so we can check the surveying collecting result from other group members. So here we can see there's a different pictures and videos. So we can check the pictures. And also we can check the videos from another operators and so this is really nice effect and powerful for the cowork surveying. Okay, even in the really far away distance in China, we can also do that thing. So this is check another guys from Sichuan, okay, also check the video and photo. All right, so here is about the AR modeling result. Okay, for AR modeling application, so we can display the AR modeling result based on the coordinate data collected from the field collection process. So this is, in this video, is about the example of the combination with AR map and real world survey result. So here we see a model of the wild cover. Here we can check the detail, okay, the detailed data set with a name or something else, or and we can also change the format. Okay, we can close or open the traffic light, okay, with the beam model, okay, in the AR map. So the basic data was provided by the our real world survey task. Okay, so this is really a great combination, okay, and really great way to show this. And in the end, it's about the customized development. So we support customized interface based on that tablet, and we can rebuild a base framework for business customization. And I see the time is really near, and the time is here, and I will have a really brief introduction about here. And of course, our PPT will our PowerPoint will share with you guys as a PDF format, and you can check with these with our these files, okay, later with yourself. I just will have a brief introduction about that. And we customize interface. We can customize the interface. Okay, we have the for the icon, for the launching page, or even build the native environment. Okay, for the configuration of file structures, we can configure it, the homepage model customization, and the interface configuration, function toolbar, or something else. And here's about the brief introduction, okay, and the description of the common components. Okay, and here's about the business customization. And we can in isolation the demo. Okay, we can get the demo and download the related package and demonstration data. Okay, and for the Android, for the iOS, we have different data, of course. Okay, and we have the product configuration. We can run the demo for the Android and iOS. And here's some example of conducting navigation. And here, in the end, we have a comparison. Oops. Here we have a comparison video of the customized start page and interface. Okay, that brief shows some basic customize we realize in the tablet application. Okay, so here this is about the, so first about customized start page. Okay, and it's about the home page or the index. Okay, here we can customize the menu bar here. Okay, we can also customize the toolbar here, okay, to use a different icon or add some different functions into our tablet. Okay, so here's my today's introduction about the tablet, and thank you guys for you listening. And I'm sorry for my website. I'm sorry for my web situation. Okay, so thank you guys.